pueden levantar los brazos para saludar a Brian. Gracias. También tenemos a CCH Naucalpan. Si los jóvenes de CCH Naucalpan pueden saludar a Brian. Y está por llegar seguramente un grupo en Prepa 7. Please give us 5 minutes. We are preparing the last details.
Perfecto. As I understand, Pedro, you are going to be running the slides locally there, correct?
Yes, every site have the slides. I'm going to put the slides on the screen, and you can tell us which one continue.
Perfecto.
Sí, buenos días. Quiero verificar si en Prepa 7 los esperamos un momento más. Si alguien en Prepa 7 me dice si esperamos unos minutos más. Brian, can you give us 2 minutes more?
Sí, no problema.
Gracias. Prepa 7, alguien en Prepa 7 si me indica si podemos empezar o si esperamos unos minutos más. Si abren el micrófono. Sí, en Prepa 7, en la interfase del programa, si activan el icono del micrófono y me indican si esperamos unos minutos más.
Está llegando el grupo en estos momentos.
Correcto, entonces esperamos un par de minutos. Un favor, si me indican en Prepa 7, si les parece bien si comenzamos.
Prepa 7, ¿estamos listos?
Correcto, muchas gracias. Prepa 7, le pido por favor volver a cerrar su micrófono. Well, Brian, we are ready to start the session. Are you ready?
Yes, I am.
Okay, just give me a minute. I'm going to introduce your participation. Bueno, gracias a todas las sedes que nos acompañan. Bienvenidos a la Dirección General de Divulgación de la Ciencia, al Museo Universum. Vamos a dar inicio a la sesión del día de hoy. Como pueden ver, tenemos la conexión con Brian Day desde el Instituto Virtual de Investigación para la Exploración del Sistema Solar. Él se encuentra en California. Les voy a platicar un poquito sobre la trayectoria de Brian. Brian es psicólogo y además ingeniero en sistemas. Además, llevó a cabo estudios de posgrado en astronomía y, como ya les comenté, trabaja para el Instituto Virtual de Investigación para la Exploración del Sistema Solar de la NASA. Can I tell that you are an eclipse hunter, Brian?
Yes, yes, indeed.
Durante el evento del pasado eclipse, participó en los diferentes campus donde estuvieron realizando observaciones. Es un gran amigo del Museo Universum, un gran conferencista. Además, agradecemos mucho su participación porque acaba de cumplir años apenas hace 2 días. Entonces, congratulations, Brian, happy birthday.
Thank you.
So
Thank you.
we are ready, Brian. All the public is yours.
Very good. Thank you very much. Today, I have just gotten back from a trip to see a total solar eclipse. And so I would like to talk with you today about eclipses in general, and we will look at this most recent eclipse in particular. So moving on to slide number 2, it is important to talk about safety anytime we talk about eclipses. So looking at the sun directly with your eyes is always a very dangerous thing to do. Now, eclipses are not any more dangerous to your eyes than normally looking at the sun. The difference is you just have more of a reason to want to look up at the sun during an eclipse. So you need to get special filters, special glasses that enable you to look at the sun safely. So the next slide, we're going to talk about the basics. What is an eclipse? And a solar eclipse occurs when the moon comes between the sun and the earth. The moon makes an orbit around the earth in approximately every 28 days. And so you might wonder, why do we not see a solar eclipse every 28 days? Well, the next slide shows us why. It is because the orbit of the moon around the earth is tilted when compared to the orbit of the earth around the sun. That means that sometimes when the moon comes between the sun and the earth, the moon's shadow passes below the earth. At other times, the moon's shadow passes above the earth. And it is only when things line up perfectly so that when the moon comes between the earth and the sun, and it happens to be crossing the plane of the earth's orbit around the sun, that's when we have the opportunity to see an eclipse here on the earth. So it is much rarer than just once every month. In the next slide, we'll take a look at the different types of solar eclipses. So there is the instance of a partial eclipse, which happens when the shadow of the moon perhaps just barely misses the earth. It passes just above the earth or just below the earth. And parts of the earth may see just a portion of the sun covered by the moon. So the moon does not ever completely cover the sun, it just covers a part of the sun. Now you can also see a partial eclipse during an instance when the moon's shadow actually does touch the earth, but you are standing just outside of that shadow. So if you are not in that central shadow, then even though there might be a total eclipse, what you will see is a partial. Another type of eclipse is, of course, the total eclipse, and that's where you are precisely in line between the sun and the moon. And so the moon is blocking the disk of the sun, and you are standing directly in the moon's shadow. That is a total eclipse. But then there is yet a third type of eclipse that we call an annular eclipse. And there, again, the alignment is perfect. The sun, the moon, and the earth are perfectly lined up. But the moon does not go around the earth in a circle. It goes around the earth in an ellipse, kind of a squash circle. And the same thing about how the Earth goes around the sun. Not in a circle, but in an ellipse. So what that means is sometimes the moon appears bigger in the sky when we're closer to it, and smaller when we're further away. And similarly, the sun can appear bigger and smaller, depending on our orbit. And so you can have situations where you have a perfect lineup, center for center, but the moon appears smaller in the sky than the sun. In that case, the moon does not cover the entire sun. Instead, the sun becomes a bright ring in the sky. That is an annular eclipse. So let's take a look on the next slide at a typical map of the moon's shadow on the Earth during an eclipse. The dark pair of narrow lines in the center mark the path of totality, the path of where the shadow of the moon is crossing the Earth. That is where you will see a total eclipse. Then you will notice bands on either side of that. Those are areas where you will see a partial eclipse. So for instance, you can see, looking at the lines going down below totality, you can see an area of 80%, 60%, 40%, 20%. So those are areas where you would see a partial eclipse. Now this map is for the most recent total solar eclipse. And you will notice that Mexico is actually in the area of partial. So perhaps some of you saw this eclipse as a partial eclipse. The next slide is an animation that shows how all of this works. The small dot, dark dot moving across the land, that is the moon's shadow. That is where people see totality. But then the much larger, somewhat darkened area around it is the area where people will see a partial eclipse. So you have a total eclipse surrounded by a partial eclipse. In the next slide, we see an example of a map of an eclipse, but this is one of those cases where the moon's shadow does not actually touch the Earth. The moon's shadow passed just above the North Pole of the Earth. And so nowhere was there a total eclipse seen. But parts of the Earth did see a partial eclipse. And this happens to be the partial solar eclipse of 2014, October 23rd. And if you take a look at this map, you will see that the Baja Peninsula of Mexico is within the area of the partial eclipse. And the city of La Paz in Baja saw something over 20% of the sun covered by the moon. I was in La Paz for this particular eclipse. And here's what it looked like. Next slide. Even though it was just a partial eclipse, and I'm hoping you're able to see the whole slide here, you should see the water at the bottom. This is the eclipse over the bay in La Paz. And it is taken with multiple exposures, a filter over the camera, except for the last exposure, the sun set, and then the filter came off, and that revealed the background of the Bay of La Paz. So even a partial eclipse can be very beautiful. And there were some very special things about this eclipse. In the next slide, we see a view through my telescope during the eclipse. And you can see that there was a wonderful big group of sunspots out that day. We'll talk more about sunspots later in this talk. Another special thing about this eclipse is it happened during Semana de la Ciencia. I did not realize that when I was there. I set up my telescope on the Malecon in La Paz. And I was surprised when I had 400 students come gather around my telescope to look. It was wonderful. Fortunately, I brought a lot of eclipse glasses with me, and we all enjoyed the eclipse together. It was a very special occasion. In the next slide, we see an example of an annular eclipse. This was taken at the Grand Canyon. And in this case, the moon came directly between the Earth and the sun. But the moon was too small in the sky to cover the sun. And so you can see in the center of the pictures here, the sun did not disappear, but instead turned into a bright ring in the sky. In the next slide, we see another example of an annular eclipse. This one was in Texas in 1994. And again, you can see how the sun turns into this bright ring. You still need a filter at this point to look at it safely. In the next slide, we see a beautiful eclipse that again I took this picture in Mexico. This was in 2002, south of Todos Santos. And this eclipse, if I had been on a ship out at sea to the south, it would have been an annular eclipse. But because I was outside of that central path, what I saw was this very beautiful partial eclipse. So you can see how there are different types of eclipses. Of course, the type of solar eclipse we are most interested in is the total solar eclipse. And in the next slide, we see some of the important parts of what we are looking for. During a total solar eclipse, the sun's bright disk, or photosphere, is covered by the moon. The last little pieces of the photosphere to disappear may shine through valleys on the edge of the moon and be blocked by hills and mountain peaks on the edge, and so broken up into beads. You see bright and dark areas right along the edge. We call those the Bailey's beads. Then around the sun, or around the disk of the moon, you will see the chromosphere, pink layer, and this is the sun's inner atmosphere. It is something that is very spectacular to see. And then above that, you have the corona, the sun's outer atmosphere. During totality, you take your eclipse glasses off and you look up in the sky and you see this safely with your own eyes. In the next slide, I show an example of some of those beads I was talking about. So you can see at the bottom of the eclipse there, you can see how the sun's surface is broken into light areas and dark areas. The dark areas are where mountain peaks and hills are sticking up, and the bright areas are valleys, are low spots on the edge of the moon. And so that breaks up the sun's surface into these bright and low areas. Now, the last bit of the sun that disappears in the next slide, we can see it's very bright, and then you see the corona around it, the sun's outer atmosphere. But we call this effect the diamond ring effect, and you can see why. It's very beautiful to look at. So in the next slide, we will take a look at the map of the eclipse that we just had. And you can see that the path of totality crossed all of the way across the United States, from west to east, from Oregon in the west to South Carolina in the east. And if you wanted to see total solar eclipse, you had to put yourself inside that very, very narrow path. The next slide shows a bit closer view. of the path of totality going through the United States. The longest duration you can see is marked with that little blue point. That is not where I went to view the eclipse, though. That would have been about 2.5 minutes. Instead, I went to Oregon, on the far left of this picture. And I went there because that's where the chances were best in terms of weather. A long eclipse, if it's behind clouds, is no fun to watch. So I sacrificed a few seconds of totality to be in a sky that I felt would be very clear. The next slide shows just where in Oregon we were, and actually I was on the eastern edge of Oregon, right there on the border between Oregon and Idaho. And that's where the weather prediction was that it would be the best. So now let's take a look at how the eclipse appeared from Oregon. In the next slide, we see the partial phase began for us at 10, 10, and 8 seconds in the morning. A number of small sunspots can be seen on the disk of the sun. They provided variety and helped us focus our cameras and telescopes. For the next 1 hour, 15 minutes, and 27 seconds, we watched the moon advance in front of the sun toward totality. Next slide. The excitement is building. Here you are. The weather remains great. The sky is wonderfully free of clouds and also free of the thick smoke that blanketed other parts of Oregon. It is getting noticeably dimmer and quite a bit cooler. Venus has become visible in the sky. Members of the people in our group are using all kinds of ways to project pinhole images of the sun and see crescents on the ground. Next slide. Now we're starting to get confident, and we realize that this is really going to happen. Next slide, please. You hear people yelling, "Filters off. The partial phase is ending." This is the diamond ring that we talked about. But you'll notice that in this position, there's a mountain sticking up right in the middle of that diamond ring, and so it broke it into 2 diamonds. At this point, the moon's shadow can be seen darkening the western horizon, and it quickly grows larger as the shadow approaches us at over 1,000 miles an hour. Next slide, please. Here we see Bailey's beads, those beads at the very bottom. Those are the final glimpses of the photosphere before totality. In the next slide, we have a closer view of those beads. Next slide. We are now in full totality. You can see the chromosphere, the sun's inner atmosphere, showing up as that thin pink layer beneath the white glow of the sun's outer atmosphere, or corona. Next slide. As the moon's disk continues to move across the sun, it uncovers giant flame-like prominences erupting off the edge of the sun. In the next slide, we have a closer view of those prominences. And that prominence in the upper right there, that is probably, I would guess, maybe 7 or 8 times as tall as the Earth. Next slide. As we increase the exposure time, we reveal more detail in the inner corona. In the next slide, longer exposures bring out more of the fainter details further out in the corona, but overexpose the brighter inner areas. Next slide. Jets and streamers become evident in the outer corona with longer and longer exposures. In the next slide, after 1 minute and 26 seconds of totality, the total phase of the eclipse comes to an end for us with a new series of Bailey's beads. The next slide, please. The beads grow, they merge, and they form a final diamond ring. In this case, we have a ruby on the side. Now, here in this slide you are looking at, this is an important point to make. The eye can see far greater ranges of brightness than can be captured in a photograph. The views with our eyes reveal details all the way from the bright chromosphere and inner corona to the much dimmer areas of the outer corona. And they did this in ways that no single photograph exposure can. But exposures of different lengths can be digitally combined and blended. The range and brightness is greatly compressed compared to what we saw with our eyes, but the range of detail now approaches what we saw with our eyes. In the next slide, we see a view of, here we are watching the eclipse. You'll notice the street lights have come on even though it's approaching noon. The sky above is dark, but all of the way around the horizon, you have sunset colors. It is a very, very spectacular thing. In the next slide, you see a picture of the telescope that I used to take these pictures. It is a fairly nice telescope. It's portable, it is relatively small, but it's a relatively fancy piece of equipment. But you don't need complicated equipment to enjoy an eclipse. In the next slide, you see a view of the eclipse that was provided by a tree. And pinhole images, you can stick a hole in a piece of cardboard and have the sun project through that hole onto the ground, or in this case, the holes between leaves of a tree will project images of the sun. So here you see many different crescents of the partial phases of the eclipse. And so you can watch the partial phases this way, and then when totality happens, you can just look right up at the sky. So it does not require very, very expensive equipment to enjoy an eclipse. Of course, we did have far more expensive equipment than my little telescope. In the next slide, you will see a view from 1 million miles out in a satellite. This is one of NASA's cameras aboard the Deep Space Climate Observatory. And if you look carefully, you can see the moon's shadow moving across the surface of the Earth. We had many views. The astronauts and the International Space Station saw it, and the Lunar Reconnaissance Orbiter spacecraft in orbit around the moon turned its camera away from the moon, looked back at the Earth to see the moon's shadow moving across the Earth too. So in the next slide, you see some of the preparation that NASA went through to share the eclipse with the public. This shows areas along the eclipse path where NASA had set up TV broadcast locations. So NASA had a television broadcast of the eclipse, and as the eclipse moved across the United States, we were able to shift from one location to another. In the next slide, you see where we had web broadcast locations. And in the next slide, you see where we had official viewing locations. These are viewing sites where people could gather and watch the eclipse together and have an expert there explaining to them what they were seeing. So we had a lot going on for people to see the eclipse in person, to see the eclipse on television, or to see the eclipse on the internet. This took a lot of preparation. In the next slide, we see how not only did we give people opportunities to view the eclipse, but we gave people opportunities to participate in the science of the eclipse, to make scientific observations and contribute their observations to the NASA science program of understanding this eclipse. One of those involved the GLOBE program, in which case people used an app on their cell phones to make measurements of changes in the weather and in the atmosphere, in the temperature, in cloud cover during an eclipse. So understanding how the Earth's atmosphere reacts to an eclipse. So people across the country use this app to contribute information. In the next slide, we see how amateur radio operators also participated in a program that measured the ionosphere, the outermost layer of the Earth's atmosphere, and saw how that changed during an eclipse. In the next slide, we see a program where NASA sent out more than 60 telescopes, identical telescopes, to schools and groups across the eclipse path and asked them to take pictures through those telescopes. Now, in any one location, you might only see 2 minutes of totality. But by lining these telescopes up all the way from the East Coast, from the West Coast to the East Coast to the United States, we were able to switch from one telescope to the other and get a total of 90 minutes of totality. And next, here's another example of a program. So the next slide, we see how life responds. Animals respond very differently to an eclipse. Birds think it's nighttime and they will go to roost. I once saw an eclipse in Africa surrounded by many wild animals, and it was fascinating to watch their responses. So part of this eclipse was to have people make observations of how animals reacted around them. The next slide. Of course, an eclipse provides wonderful opportunities to talk about the main players in the eclipse, to talk about the sun, talk about the moon, and educate people about them. The sun is the nearest star to the Earth, and it is big. If the sun were hollow, you could fit 1,300,000 Earths inside of it. It generates its heat through nuclear fusion, turning hydrogen into helium. And every second of time, 4.26 million tons of the sun's material disappear and are turned into energy. 4.26 million tons of the sun get turned into energy every second. Next slide. We can talk about the structure of the sun. The core of the sun has a temperature of 15.7 million degrees. The photosphere, that bright area of the sun that you look up and see in the sky, there now the temperature has dropped down to only 5,600 degrees. But then as you go out into the corona, for some reason, as you get further away from the sun, the temperature goes up to as high as 20 million degrees. There's a lot we are still learning about the sun. Next slide. We saw pictures of sunspots before, and sunspots are giant magnetic storms on the sun. They're areas where the temperature is cooler, perhaps 2,000 degrees cooler, because They are cooler, they aren't as bright. They appear dark in contrast. These areas can get much larger than the Earth. Next slide. We also have solar prominences, those big flame-like eruptions. Very spectacular to watch. Here you can see an example of a prominence compared to the size of the Earth. In the next, we see another view of a prominence. And here we see a prominence forming a big, beautiful arch. In the next view, we see a prominence coming out more like a spray. And again, we show the Earth in comparison. These are big eruptions. And in the next slide, we see, again, some of the amazing variety that prominences can show. But prominences are not flares. In the next slide, we take a look at flares. Flares are much more violent, much more energetic, huge titanic eruptions. They are very spectacular to watch. So here we'll take a quick look at a few flares erupting. They are rarer than prominences and much more powerful. Okay, in the next slide, we see that flares can, in some cases, cause what we call coronal mass ejections. Giant blasts of the sun's atmosphere being shot out into space. In the next slide, we see that when that material from the sun, that high-speed solar wind, travels across space, it can encounter the Earth and the Earth's magnetic field. Next slide. In those cases, that can have a profound effect on us here on Earth. It can disrupt television broadcasts, it can disrupt satellite communications, it can present dangers to our astronauts, and it can present dangers to people flying in commercial aircraft. Next slide. The sun goes through an 11-year cycle of activity, going from almost nothing here. Let's go to the next slide. We'll see a little bit of activity in terms of some sunspots. Next slide. More activity. And next slide, even more. So it goes from no activity up to a lot of activity and back down. That happens typically every 11 years. But there have been gaps. There have been prolonged minimums. And in that cases, the sun becomes cooler. And we had an example of the Little Ice Age that happened between the years 1645 to 1715. The sun directly affects us here on Earth. In the next slide, eclipses give us a chance to talk about our current missions. NASA has a number of missions that are exploring the sun. The most recent, in the next slide, is the IRIS mission, which is something that we worked on right here at NASA Ames, and the mission control room is right here at NASA Ames. This mission is going on right now. In the next slide, we also see that eclipses give us a wonderful opportunity to talk about the moon also. The moon is Earth's nearest natural neighbor in space. Its distance from the Earth varies between a little over 360,000 kilometers to a little over 400,000 kilometers. It is about 1/4 the Earth's diameter. So we had a wonderful, wonderful show with this last total solar eclipse. But there are more to come. In the next slide, you see a list of upcoming eclipses. It shows the date, the time, the type of eclipse, whether it's a partial, a total, or an annular, and what areas it will be visible from. I'm going to draw your attention to a couple. If you take a look at the eclipse of April 20th, 2023, you'll see it says that's a hybrid eclipse. That means for part of the path it will be annular, but for part of the path it will be total. So that's another interesting variation on solar eclipses. But the one that I really want to call your attention to is the eclipse of April 8, 2024. Maximum eclipse will occur going across North America and Central America, with totality being in Mexico, the United States, and Canada. Let's take a look at the map for this eclipse. Next slide. There you can see the path of totality. And it goes across both Mexico and the United States. Let's take a closer look at the Mexico portion of this. So the next slide, here we see the path of the eclipse going through Mexico. Mazatlan, Durango, a number of cities will see a total eclipse. I'm giving you plenty of notice here. This is April 8th, 2024. That's 7 years from now. But that's not too early to start planning. And I would encourage you to think about how you can have programs to bring the excitement of total solar eclipses to the public there in Mexico. It is a wonderful, amazing event. Now, I will tell you right now, too, that the Agencia Espacial Mexicana, Mexico Space Agency, and my group here at NASA are working on a partnership. And part of that partnership, I am hoping, will be to collaborate on events during this wonderful eclipse that Mexico and the United States will share together. So I hope we can have another talk in 2024 and share the wonderful experiences and amazing views that we all have of this beautiful eclipse. And with that, I will be happy to take any questions that you may have.
Muchísimas gracias, Brian. Thanks a lot. I think abrimos los micrófonos para dar un aplauso a la conferencia. Les pido a las diferentes sedes. Y en un momento vamos a iniciar con las preguntas. Les pido a todas las sedes si cierran su micrófono. En un momento les voy dando la palabra. Brian, do you think this eclipse is the most viewed eclipse? All the effort done by NASA was success in the number of viewers across the world?
Yes, this was a lot of work putting this together, but this may have been the most viewed eclipse ever in history. You had giant traffic jams of people coming together to watch the eclipse and to see it in person. But at the same time, we had, now with the internet and with our many television locations, we were able to share this eclipse all around the world. It's a lot of effort to get something like this to happen. But yes, it was very successful. And I have not seen the total count yet. In fact, after this presentation, I will be on a meeting with NASA to look at the results of all of our efforts and all of our programs, and to try and understand how many people we reached.
Please count Universum. We had 5,000, more or less, visitors.
Wonderful.
Well,
And did you have a clear view there?
okay.
Was the weather good?
No sé, allá nos dice, somebody tell us that was a good view. Voy a pasar a la ronda de preguntas. Voy a iniciar por CCH Naucalpan. Quiero verificar si en CCH Naucalpan hay alguna pregunta o comentario. Ya sea en inglés o en español, podemos ayudarlos con la traducción. Si por favor en CCH Naucalpan activan su micrófono y nos indican si hay alguna pregunta o comentario.
¿Sí está prendido?
Sí, sí los escuchamos.
From the three kinds of eclipse you said there were, which of them happens the most? I know they don't happen every week, but which one has seen most of the time?
I'm sorry, I had a little trouble hearing that. Pedro, can you repeat the question for me?
We too had a little problem. ¿Podrías repetir la pregunta un poquito más pausada, un poquito separándote del micrófono para que entendamos mejor la pregunta, por favor? Ahí.
From the three kinds of eclipse that exist, which one of them happens the most frequently?
Okay. So, the partial eclipse happens most frequently, and so that is the one that is most easy to see. The total eclipse happens somewhere on the Earth about once every year and a half, but you have to be at exactly the right place on the Earth. And so from any one location, it can be many, 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 many years before you can see a total solar eclipse. That means that you have to travel if you want to see total solar eclipses. You become an eclipse chaser. It is a very ridiculous hobby, but it is something that I do. This was my 9th total eclipse, and I have gone to many strange places. My first eclipse, the most wonderful one that I saw, was in Baja, California, Mexico, in 1991. And that hooked me. Once I saw that, I knew that I was going to travel around the world to see more total solar eclipses. And I've been to Africa. I've been to Europe to see eclipses. I've been to Australia. I was on the border of northern Mongolia and Siberia in the wintertime with 40 below zero temperature. Once you see one of these eclipses, it can capture you, and you will travel around the world just to stand in the moon's shadow again. In 2017, I plan to be in Argentina. Or excuse me, 2019. 2019, the next total solar eclipse will be in 2019, and I will need to go to Argentina to see it. But you have, like I say, in 2024, you have a total solar eclipse coming to you. And I strongly recommend that you go see it.
Gracias, CCH Naucalpan. ¿Alguna otra pregunta o comentario?
En español la pueden decir. Ahorita por el momento no, Pedro, gracias.
Correcto, voy a pasar a preparatoria 7. Quiero verificar si en prepa 7 hay alguna pregunta o comentario. Le pido a CCH Naucalpan cerrar su micrófono, por favor. Si nos activan el micrófono en prepa 7 para saber si hay alguna pregunta.
¿Prepa 7?
Sí.
Hello. I have a doubt. Talking about scientific, there's like things that could happen to, I don't know, to our phones, our computers, all the machines in general, when there's a total eclipse or something like that.
Well, the sun does affect us here on Earth. And an eclipse will not cause problems for us, specifically for our machines, for our equipment. But eruptions on the sun, those coronal mass ejections, they can. They have caused power outages across wide areas. They can disrupt communication. And so that is when the sun is very active and there are eruptions on the sun. And that's why we have observatories with telescopes monitoring the sun all of the time. As a matter of fact, when I was visiting in Ciudad Mexico, and Pedro took me to UNAM, and he took me to the Universum Science Museum, and they have there an observatory with a telescope that is used to look at the sun every day. And there was an astronomer working there, a young woman who was making measurements of the sun every day. Because as you mentioned, the activity on the sun can cause effects here on the surface of the Earth. So it is very important that we observe and study and understand the sun. And if you want to see that for yourself, as I say, the Universum has a wonderful observatory that does that. Pedro, can you tell me, is she still doing that study? Is she still working there?
Yes, Brian. We still continue with the observations.
Excellent.
¿Alguna otra pregunta o comentario en Prepa 7?
Sí.
Adelante.
Well, I haven't thought about on solar spots because, well, on solar spots because you told that there was like an increase, and actually there is like an average of how like the increase. Oh,
Oh, creo que ya le dio pena.
Si nos plantean la pregunta en español, podemos intentar traducirla. ¿Se animan a plantearla en español?
No, gracias, es todo.
Correcto. Entonces voy a pasar a Prepa 6. Quiero verificar si en Prepa 6 hay alguna pregunta o comentario. Si por favor en Prepa 6 activan su micrófono. No tenemos audio de Prepa 6. Si por favor activan su micrófono. Seguimos sin audio en Prepa 6. Sí. Veo al maestro Besné hablando en el micrófono, pero no tenemos su audio. Si por favor verifican si en la interfase está abierta la señal de audio. Vamos a esperar a little moment, please. They are preparing the microphone.
Okay. While they are preparing, let me just point out briefly that it is interesting to watch how animals react to an eclipse, but it is also very interesting to watch how people react to an eclipse. People yell, they scream, they cry, they pass out. At my first eclipse in Baja California, there were people at the hotel. It was in July in Baja, so it was very hot. And people at the hotel were standing in a swimming pool watching the eclipse. And as the eclipse approached and the excitement got more and more, this guy who was in the swimming pool turned to his girlfriend next to him and he asked her to marry him. He proposed to her in a swimming pool during an eclipse. But what was really funny is then the guy's friend who was standing right next to them in the pool says, "Hey, I was just talking to a man over there. He's a priest. We could do this right here and now." And so this couple got married in the swimming pool during an eclipse. Very strange reaction. But another example occurred in 585 BC in the area that is now the country of Turkey. There was a war going on. And all of a sudden, a total eclipse appeared in the sky. And the soldiers on both sides dropped their weapons and decided this must be some kind of a sign. And so the war came to an end and both the armies went home. So it is interesting to watch the reactions of people to eclipses too.
Yes. Voy a regresar a Prepa 6. Quiero verificar si resolvieron el problema con el micrófono.
Si hay una pregunta, bueno.
Sí, adelante, ya los escuchamos, Prepa 6.
Ah, ok. Si hay una pregunta de un alumno.
Adelante.
Yes, I didn't understand what's the purpose of iris.
The purpose of
The purpose of
Iris,
Oh, the IRIS spacecraft. Very good. So IRIS is looking at the area at the, if you will, the top of the sun's atmosphere. Because we see something very, very strange going on in the sun's atmosphere. The inner atmosphere of the sun has a temperature of only about 4,000 degrees. So that chromosphere, the lower chromosphere, is about 4,000 degrees. Then as you climb up higher and higher in the atmosphere, I would expect as you're getting further away from the sun to see the temperature drop. But instead, the temperature goes up. So as you look at the chromosphere, the lower part of the chromosphere, the temperature is 4,000 degrees. At the top of the chromosphere, it is 20,000 degrees. And then you move into the corona, the upper atmosphere, and the temperature climbs to 2 million degrees and can get as high as 20 million degrees. So why does the temperature go up as you're getting further away? Something very interesting is happening. And so somehow energy is getting pumped from inside the sun into the atmosphere of the sun. And that is what IRIS is studying. It is studying this transition from the low temperature to the high temperature part of the atmosphere and looking at what the physics is of what is going on, trying to understand how the sun is increasing the temperature there. Excellent question.
Thank you.
Gracias, Prepa 6. ¿Alguna otra pregunta o comentario?
Hi, I want to know what's the importance to study an eclipse, because always had been an eclipse and why it's different every one.
Okay. During an eclipse, people gather to study eclipses because, for one thing, they're beautiful to look at, but also they allow us to view parts of the sun that we normally don't get to see. We normally don't get to see the corona. We normally don't get to see this outer atmosphere of the sun. Eclipses give us a unique opportunity to see that, especially the inner part of the corona. Eclipses have also been used to understand Einstein's theory of general relativity, about how mass can actually bend space around it. And people tested this out during total solar eclipses, because as the sun is covered by the moon, then stars near the sun, or in the same line of sight as the sun, can now be seen. So in daytime, you are able to see stars near the sun. During this last eclipse, inside the corona of the sun, we were able to see the bright star Regulus in the constellation of Leo. But what happens is, because the line of sight is going close to the sun, we see space actually get bent, and the position of the star in the sky actually changes because of the fact that our line of sight is going past the sun. And so we are able to measure how the mass of the sun is actually bending space around it. So that is one of the more sophisticated things that we study during an eclipse. But we also study how it affects our atmosphere here on Earth. Excellent question.
Gracias, Prepa 6. ¿Alguna última pregunta en esta ronda?
Sí, todavía hay una pregunta más.
Adelante.
Can you tell us about your experience in the last eclipse?
¿Podrían repetir, por favor, un poquito más pausado?
Can you tell us about your experience the last eclipse?
I'm sorry, I did not hear that.
About your experience in this eclipse, where were you viewing the eclipse, and what was the environment of your observations?
Okay. Yes, so I was in eastern Oregon, and eastern Oregon is a desert area. So you have a big, tall line of volcanic mountains to the west of us, and that blocks the wet air coming in from the Pacific Ocean. And so on the west side of those big mountains, you have a very thick rainforest, which is probably a bad place to go to watch an eclipse. But on the east side of those mountains, the air is very dry, and it is a desert, and so the chances of the weather being good were much better. So it was warm, it was clear, and it was dry. It was perfect environment for watching an eclipse. But as we experienced the eclipse, we felt the temperature drop. It started out very warm indeed. But as the eclipse progressed, the temperature dropped down and it became nice and cool. And then at the end of the eclipse, it got hot again. It's a very interesting thing. Eclipses are something you see with your eyes, but you also feel it in terms of the temperature change. You hear it in terms of the reactions of birds and animals around you. It is an event for all of your senses.
Gracias, Prepa 6. Vamos a las preguntas de Universum. Here at Universum, the first question.
Tengo como 3 preguntas, pero voy a ser breve. En primer lugar, pues que nos digan hasta ahorita lo que se ha aprendido de este eclipse, que sería lo más sobresaliente o diferente a otros eclipses o algo novedoso. Observo también que la corona solar o esta luz blanca que vemos, no sé si sea su nombre correcto, es más pequeña que en otros eclipses. Quiero saber si esto se debe a actividad solar o a distancia de la luna al taparla, que esté más cercana a nosotros, que la veo menor. Pues dejemos
voy a traducir la primera pregunta. NASA learned something new with these studies of this eclipse. Did you learn something new about the sun or the moon with this large study of the eclipse?
Well, that is something that I hope to learn in this meeting that I'm about to have when we finish here. We're having many people who participated in this eclipse throughout NASA, all getting together to talk about what we experienced. One of the things that we are looking at especially is that activity in the inner corona, the lower part of the corona, and seeing about the energy flow from inside the sun through perhaps magnetic field lines into that inner corona. And so to better understand it, we launched many high altitude balloons all along the path of the eclipse to image the sun. We had aircraft flying along the path, and of course we had observations from space. So we're now just at the stage of beginning to gather all of that data. There will be many discussions about what we have learned. But the idea of being able to set up telescopes, identical telescopes, all along the path, and so to be able to essentially create 90 minutes of totality, that is very special. When we look at changes in the corona, if you only have one viewpoint, you're essentially taking a snapshot, just one point in time. And so trying to understand how the inner corona changes can be very difficult. But by assembling all of these views all along the path and getting the opportunity to essentially see totality for 90 minutes, now that adds a new dimension. That adds the dimension of time, so that we can really look at how the corona changes over time. So I am going to be very interested to see the results of that, what we call the Kate experiment, and looking at that long duration of totality.
Gracias.
As we find out, we'll let you know.
Okay. Thank you, Brian. The second question is the images you showed. We see the corona thin, not too bright as on other occasions in another eclipse. Is there any reason about the thing of the corona?
So every eclipse is different. But one of the things that we do see is that the shape of the corona and the structure of the corona are tied to that 11-year cycle that we talked about. And so in the case of an eclipse that happens near maximum solar activity, the corona is big and broad and almost round. It is much more even all the way around the sun. But in the case of an eclipse that happens near a minimum of solar activity, and that's where we are right now, then you see a much different shape to the solar corona. And you see kind of a thinner, more stretched out corona. And so the corona that we saw for this eclipse looked very much like how we had predicted. This was a very typical, what we would call a solar minimum shaped corona. But yes, each eclipse is very, very, very different.
Thank you, Brian. Colegio Carol Borg nos sigue por internet. Colegio Carol Borg is watching the web streaming and want to know. They want to know: is there any place in the planet with more frequency of eclipses?
No, actually, the paths of total eclipses move essentially randomly across the face of the Earth. There is a town called Carbondale, Illinois. And Carbondale, Illinois, on this particular eclipse, was very close to the longest duration of totality. But one of the more interesting things that happens is that in the 2024 eclipse, that town will once again be in the eclipse path. It is where those two different eclipse paths meet, is in that town of Carbondale. So they think they are very, very special. Again, that is random. You typically have to travel to all kinds of places to see eclipses, and there's no one place on the Earth that gets them more than other places.
Here is the next question.
Thank you very much. I'd like to know, do you have some estimated time for the 2024 eclipse, and in which part of the solar cycle we are going to be?
Okay, so in terms of 2024, little more detail about it. The maximum duration of the eclipse for this last one that we saw was about 2.5 minutes. In the case of the 2024 eclipse, it will be 4 minutes and 28 seconds. So much longer totality. That is a very good thing. And as I recall, let me switch my slide to it, that will actually occur, yes, that will occur in Mexico. So that is a wonderful thing. The time is, that will be at 18:18:29 universal time. That's the maximum of the eclipse. So your local time in Mexico depends on what time, when you do the transition to daylight savings time. But that will be essentially in the late morning. So again, from a weather standpoint, that is good. So April 8th, 2024, universal time of 18:18:29 will be essentially the time of greatest eclipse. And that happens in Mexico and will last for 4 minutes and 28 seconds. All of that is really good news.
Thank you, Brian. Here is the last question from Universum.
Good morning. During the eclipse, does the air receive more X radiation than another condition?
Actually, during an eclipse, we get less radiation because the moon is actually blocking part of the sun. And that actually caused some problems for us here in the United States, especially here in California, because we get a lot of our energy, our electrical energy, from solar power. We have many, many cases of solar cells being set up around the state to gather the sun's energy and turn it into electricity. But during the eclipse, we had part of the sun getting covered up, and so we had less energy, less electricity available here, and the power companies actually had to plan for that.
Thank you, Brian. Voy a pasar a CCH Naucalpan para saber si hay una última pregunta o comentario. Si por favor nos indican si en CCH hay alguna última pregunta o comentario.
Sí, en un momentito, por favor.
Correcto. Adelante. Oh, perdimos su audio. Si pueden hablar un poquito más fuerte.
Okay. How many steps has the last solar eclipse?
¿Podrían repetir, por favor, un poquito más despacio?
How many steps has the last solar eclipse?
¿Cuánto dinero gastaron en la cobertura de este eclipse? ¿Es la pregunta?
No, ¿cuántas etapas tuvo el último eclipse?
How many steps or station could we saw during the last eclipse?
So NASA had, I forget the exact number, but it was dozens of stations, more than 20, set up for public viewing. Probably much more than 20, actually. I can find out a list, but then you had individuals and colleges and schools setting up their own observations. You had libraries. So all along the path of the eclipse, we had many national parks and state parks. And so there were hundreds of locations across that eclipse path. There were many hundreds of locations where people were viewing the eclipse altogether. So it was huge. Like I say, this was probably the most viewed eclipse in history.
Gracias, Brian. But how would the stages of the eclipse? Can you tell us about different stages of the eclipse in this particular eclipse?
Oh, different stages of the eclipse?
Yes.
Oh, okay, wonderful. So the way an eclipse appears is as the partial phase begins and the moon just starts to cover the disk of the sun, you may not notice anything at all. And unless you have the special eclipse glasses, you probably wouldn't know that anything was going on. And that partial phase lasts for a little over an hour. As the sun gets more and more covered by the moon, it starts to get darker and it starts to get cooler. And so maybe about 15 minutes before totality, you are noticing that the sun, even though it is high in the sky, the sky is starting to look dimmer, almost like late afternoon or just before sunset. A few minutes before totality, the brighter planets pop out in the sky. We could see Venus. Sometimes you can see Jupiter or Mars. And the skies can sometimes take on kind of a silver color that I have only seen during eclipses. A few seconds before totality, you look to the west, and off the western horizon, you see this big dark shadow come charging out of the horizon. It looks like some big dark tidal wave bearing down on you at over 1,000 miles an hour. It is the moon's shadow in our atmosphere. And as it comes, it washes over you. The ground is covered in zebra-striped shadows racing across the ground. You look up, the sky becomes dark. Where the sun was, there is a black circle. You take your eclipse glasses off, and now you see the jets and streamers of the solar corona. The sky above is dark. You see the planets and the brighter stars, and all the way around the horizon, you have 360 degrees of sunset colors. As I say, at this point, people are yelling, people are screaming, people are crying. One time I was at an eclipse in Bolivia, and we had a detachment, we had a group of the Bolivian army who was there to guard us. And when totality happened, you saw these soldiers with their rifles drop to their knees and cry at how beautiful the view was. You feel it, the temperature drops, you hear it, you gaze up at that solar corona, and then you see the diamond ring as totality ends, and you look to the east, and you see the moon's shadow go charging off over the horizon. So there are many different things to look for during the stages of an eclipse. It is a very exciting, very wonderful, beautiful thing. And so before the 2024 eclipse, we must all have a meeting to plan out what you are going to see and make sure everybody is ready for this.
We will need a second video conference to prepare the 2024 eclipse, Brian.
Excellent. I hope to be watching it in Mazatlan.
Okay. The last question here at Universum.
Yes, I would like to know if the animals react to all the types of eclipse or only to the total ones.
Typically only the total eclipse. As long as part of the sun remains visible, it still stays bright out. It is only when the sun's photosphere is covered that you have this dramatic change. So it has been said that the difference between 99.9% and 100% of the sun being covered is several thousand%. A friend of mine who was at the eclipse compared a partial eclipse to a total eclipse as being like the difference between a first date and a honeymoon. So the animals see this too. And it is during totality that you see this really big change in the behavior of animals. Now, I will say though, when I was in Africa and we were all set up with our telescopes, even before totality, the animals definitely were reacting, but that was probably because of our presence there. Because, here you have this big group of people, and we were getting very excited as totality approached, and they sensed our excitement, and so they started getting excited even before the eclipse became total.
Voy a pedir a los participantes si abren su micrófono y agradecemos la conferencia con un aplauso. Thank you, Brian. It was a great conference.
Thank you so much, Pedro. It was wonderful talking to you again and to these wonderful, brilliant students. Thank you very much, and I look forward to seeing you in Mexico in 2024 for a beautiful eclipse.
Okay. There's a lot of person want to join. Bye.
Bye.
gracias a las sedes que nos acompañaron, terminamos la transmisión.